how to graph a quadratic. All right, so what we're going to do is first find the vertex and plot. So if you look at your equation, your vertex, remember, is the opposite of the number in parentheses, since the function has a subtraction sign in it, same as the number on the outside. So our vertex will be 3, 1. Okay, so let's go ahead and plot that vertex, 3, 1. All right, next, it might be helpful to sketch out that parent function from your new vertex. Remember, we're going to let that new vertex, think of that as like your 0, 0. So lightly here, I'm going to, I'll do it in both. There we go. I'm going to sketch out those original points. So the original point was 0, 0, then we had 1, 1. Then we had, if you square the 2, 2 squared would be 4. 3 squared would be 9. You can also do the negative ones. I didn't put the negative ones on my graph, but that would be your initial quadratic. So I'm going to erase this in a second, but it just kind of helps you give you the idea of that original parent graph just shifted 3 to the right and up 1. Okay? From there, I need to include that stretch. Okay? So think about how that vertical stretch of -2 is going to affect this graph. All right, so let's forget about the negative for a minute and just think if it's stretched by a factor of 2. So think of this as your new 0, 0, okay, your new origin, that point where your vertex was. So that line is kind of like your 0 line, y equals 0. So if I want to stretch it by a factor of 2, each of those points from that line will get twice as far away. So right now is up 1, we're going to double that. Okay, this one was up 4 from that line, so now it would be up 8. Over here, double it, up 8. Okay, so what's going to happen is just going to get skinnier. Okay, it's getting stretched out. All right, so now we wanted to do one more thing after we stretched it. We want to reflect it in the, reflect it over that upside down, over the x-axis, okay? So our starting point was still 3, 1, but now we just want to flip it upside down. So if we flip it upside down, instead of, again, our points being over 1, down 1, I wanted to stretch this by a factor of 2. So it's going to be over 1, but down 2 from that vertex. Okay, then over 2, normally it would be down 4, but since I'm doubling that, it's going to be down 8. So 4, 5, 6. Just barely hanging off the screen here. Okay, then we can do on the other side, if I would go left 1, squared is 1. But I want to double it. So I'm going to go down to -2. 2 squared is 4, but double that. So go to -8. Oh, go down 8, I guess. It's not at -8, it would be at -7. And then you can connect the dots. You could also think about just taking that y value times -2 each time. So like the one from that new XY axis, our vertex, normally I would go to the right 1 and then up 1, but since I want this stretched by -2, I'm going to go to the right 1 and down 2. That was -2. Okay, the next one, normally I would go to the right 2 and up 4, 2, 4, but since I want it stretched by -2, I'm going to go to the right 2, but down 8. So that's where we went, right 2, down 1, 2, 3, 4, 5, 6, 7, 8. Okay, finally, one last way you can do that, if all of these methods are not working for you to understand how to do the graphing, you could take that original function and just plug in points. I'll show you how to do that here in just a second. Okay, so since we knew the vertex was at 3, we could try maybe like we already know 3, 1 is the vertex. So if I plug 3 in there, I should be getting 1. We could try plugging in maybe 4 and 5 to see what those would be. So if I take that original function, take -2 times, and I plug in my 4, -2 times 4 minus 3 squared plus 1, what do I get? So -2 times 1 is -2 plus 1 would be -1. So 4, -1. So if you go and look at our graph, we can see that there is in fact a point at 4 and -1. That's always a way to do it. This way is not the most efficient way, but if you're struggling with understanding the transformations, this is another method you can always use. So if I want to try this again for the next point, I could do -2 times 5 minus 3 squared plus 1. Again, I didn't just start at 0, 1, do -1 for my table because I already knew the vertex was at 3. So I already knew that's going to be the top or bottom of my graph. I just need to know where to go from there. All right, so if I plug in 5 for x, we're going to get -2 times 2 squared plus 1, -8 plus 1 is -7. So if I go over 5 and down 7, that should be on my graph. And again, that was the one that kind of ran off the page. Okay? So you can always do it this way. I would recommend you try to do it the other way first. Let's try another one with a fraction. All right, so find the vertex. So I did the same vertex as we did on the first one, just so for some consistency here, 3, 1. Okay. I might think about what that parent function looks like. So 1, 1, 2 squared is 4. Got our negatives. There we go. And then what I want to do is I want to have a vertical stretch of -3/2. So remember, this point, the vertex ends up being like your new x and y axis. So now from there, where am I going to go? So what we can do is take each of these y values times that stretch. So our stretch was -3/2. Okay, so 1 times -3/2, that's going to be the new point of 1 and then -3/2, or -1.5. The next point, the y was at 4, so 1.5 of 4. So at 2, normally I'd go over 2 and up 4, but since I'm vertically stretching this by a factor of -3/2, that would end up being -6. Okay, 1.5 times 4 would be -6. Next, we've got 3, 9 would be the point I would normally plot. So from this dot over 3 and up 9, but I want to take that times 1.5, so 9 and another half of 9. So that would end up being, half of 9 would be 4.5, so -13.5. If I wanted to do 4, just to try that, 1.5 of 16 would be, so half of 16 is 8, plus 16 would have been 24. So obviously those aren't going to fit on my graph paper, but I wanted you to see how to do those. Okay, from there we can graph those points from that vertex. All right, so from that vertex, normally I would go 1, 1, but since I wanted it 1.5, and negative, I'm going to go 1, -1.5. For 2, from the vertex, normally we would go 2. 2 squared is 4. But since I need to multiply my vertical stretch by -1.5, it's going to be 2, -6. So we're going to start at the vertex and go right 2 down 1, 2, 3, 4, 5, 6. And then you can do the mirror image. And then go ahead and connect the dots. So there's your graph. And then if that method doesn't work for you, you can do it the same way we did that other example, and just plug in points to your original function. All right, make sure you email me if you guys have any questions.